Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It is my great pleasure to introduce Matt Bremer. He is finishing up his PhD in the InfoBiz group at the University of British Columbia in Canada. So Matt is one of the very few students of Tamara Munjunar, who Natalia and I jokingly call the queen of InfoBiz. And Matt has done an impressive set of work for the design and evaluation of visualization systems and techniques in several application domains, such as data journalism and energy conservation. And we were very lucky to have him as an intern last summer, and many of you already chatted with him. So without further ado, here is our speaker of the day.
Okay, thank you. Okay, so thank you for having me. It's good to see many of you again. I look forward to meeting those of you who I don't already know. Today I'll tell you a bit about my research. The title might have changed from when the abstract went out, but I'll tell you about a few of my projects today. So as an outline for my talk, I'll begin by telling you a bit about myself and my background. I'll talk about the breadth of my visualization projects that I've worked on. I'll follow up with some depth, in which I'll discuss some of the projects that I've worked on and their contributions in detail. And I'll finish with some future research goals and interests, and why I think MSR is the place to conduct this visualization research. So by now, some of you might have read my brief bio, but in any case, now I get to elaborate on who I am, my background, and some of the experience that I bring. So I self-identify as a visualization design and user experience researcher, a role in which I aim to understand why and how people are using visualization tools and techniques, and better ways to design these and improve these experiences. So I'll begin by telling you a bit about my academic background, which I would describe as being multidisciplinary. I started with an undergraduate degree in cognitive science from Queen's University in Kingston, Ontario, Canada. And this is where I initially became interested in human-computer interaction research. I also got my start here as an undergraduate research assistant. In this case, it was in a lab that investigated the potential of exercise video games, or active games. I looked at the interactions between exercise intensity and the ability to perform fun yet challenging cognitive tasks at the same time, similar to those that you'd find in non-active video games. Also during this period, I developed a software toolkit to allow people with different input peripherals, like different models of exercise bicycles or different models of heart rate monitors, to play games together, play the same active game. And this is in a Future Play paper back in 2010. I'm not going to speak about this work today, but just the reason that I bring it up is just to illustrate some of the breadth of my experience and familiarity with different areas of HCI research. So prior to turning my attention to visualization, my master's work, it was in human-computer interaction, and it was also done at the University of British Columbia. This was some experimental work. This is on task switching and interruptions, and their impact on older adults and younger adults' performance on computer-based tasks of varying cognitive demand. And this is work that I'd done with my advisor at the time, Joanna McGrenery, as well as Claudia Yakova from the UBC Faculty of Medicine. So like my undergrad research, I'm not going to speak about this work today, but if you're curious, you can definitely talk to me about this offline, or we have a CHI 2012 paper about this. Okay, so my PhD, as Bangshan mentioned, focused in information visualization. My dissertation shares the same title as this talk, so why visualization, task abstraction for analysis and design. It's currently being reviewed by my examination committee. I'll be defending it at some point in late March or early April, but you can read it now if you want at this URL. So it documents 4 visualization research projects that I've been working on over the past 5 years, along with my advisor, Tamara Munjunar. And over this time, I've also benefited from the contributions and perspectives of my committee members, Joanna McGrenery from Human-Computer Interaction, and also Ron Rensink from Psychology, focuses on vision science research. So I want to emphasize that all my degrees were affiliated with computer science or computing departments, but also during this time I had the flexibility with these cognitive science and HCI programs to take courses outside of this field and do courses in psychology and scene perception, psychology of reading, a few other interesting courses in visual display design, as well as courses in linguistics, statistics, research methods. So I've also spent some time working in industry and in industry research. So as Bangshan already mentioned, I was an intern here last summer working with Bangshan, Natalie, and postdoc Benjamin Bach. I worked on a design space and prototype tool for interactive storytelling with timelines. Actually, you're seeing work here on these slides already. I produced these timelines that you see on these slides using this environment. We currently have a journal paper about this work in preparation. And I'll speak more about this project later in the talk when I go deep into this project. And I'll spend some time talking about ideas and where I want to take this work next. So in 2013, before this, I was awarded a graduate research internship award from MyTax, which is a Canadian research funding agency. And this was to collaborate with a company called Pulse Energy, and a software company based out of Vancouver, who've since in the meantime been acquired by the American company Enernoc. And for several months, I embedded myself at this company, working alongside some of their client services team, their software developers, and even some of their clients across North America and the UK to design a visualization tool for organizational energy analysis and management. So I presented this work at IEEE InfoVis conference last fall. And you'll hear more about this as I go into this project in detail in this talk as well. So finally, before I started grad school, I spent 16 months interning with EMC. And this is where I did a mix of user experience research, user interface design, front-end development, and this was on a content management application. And this was intended for use in the automotive industry. This is my first real opportunity to apply what I'd learned in my undergrad HCI curriculum to a real product. And because of the length of this internship, I was able to see the product that I worked on deployed to clients during this time, which is really cool. So in the last part of this autobiographical section of this talk, I just want to summarize the reasons why I came to be a visualization researcher, why I was attracted to this area. Well, first, I was initially attracted to this research because at the end of my undergraduate program, this was combining the topics that I found most interesting in my cognitive science curriculum: visual perception, HCI, data mining. And while these topics drew me in, what hooked me was the opportunity to develop and improve upon methods. So I believed 5 years ago, and I still do, that visualization design and evaluation presents some unique challenges and requires some unique solutions and creative solutions. So finally, I'm a visualization researcher because, well, visualization itself, it's a young field and still maturing and it's growing. And especially over the past decade, and especially since I started my graduate program, the visualization practitioner community has grown considerably, which includes those working in data journalism and storytelling, those working in the business intelligence domain, and those using visualization tools and techniques for discovery in various scientific domains. So all this points to a growing literacy and demand for visualization techniques, tools, and artifacts. And it's possible through visualization research to support this growth and affect a large and diverse population of adopters. So now that you know me a little bit better, I want to give just an overview of the breadth of some of the research that I've done before I go deep into a couple of these projects. So I thought I'd briefly preface this summary with an argument for, well, why do we need visualization research? So visualization, in my perspective, it's not a singular thing. It's not a noun. And I feel that this quote from visualization practitioner and artist Jer Thorpe, it captures this mentality that by thinking about visualization as a process instead of an outcome, we arm ourselves with an incredibly powerful thinking tool. So for many people, visualization may be synonymous with the artifact, with an image, a chart, or an interactive graphic, or a particular tool. To me, visualization is this process that can be studied and broken down into components. And these components include understanding the data that's to be visualized, understanding the tasks of the people who will be using the visualization tool, artifact, or technique, as well as the surrounding context in which these techniques take place, these tasks take place. And given this combination of data and tasks, selecting and assessing appropriate visual encoding and interaction design choices. So visualization research exists because the parts of this process are seldom straightforward, especially when we're confronted with complex tasks and complex data. So while the emphasis in my dissertation, as you saw in the title, is certainly on understanding the tasks that people use visualization for, my research certainly touches on all parts of this process. So over the past 5 years, I've also had the opportunity to be involved in various forms of visualization research, at least according to the types of papers that appear regularly in visualization research venues. So I'm perhaps most well known within the visualization research community for a framework for visualization task analysis. So this is a framework that I use to guide the design and evaluation aspects of my other dissertation projects. And I'll discuss this as one of my selected projects in a few moments in detail. My work that I did here in collaboration with MSR, which pertains to interactive storytelling with timelines, that in my view constitutes a more technique-driven research, exploring a design space of a certain technique. I have two projects that would constitute problem-driven or design study, as it's called in the visualization community work, one in which we design for a specific application domain and problem. So one's in the journalism domain, and another in energy management. And I'll speak about the energy management project in detail. And finally, I've also had an opportunity to collaborate on a system development project in which we built an authoring tool called Timeline Curator for extracting and presenting timelines from unstructured text, which was at FAST last year. So another theme that cross-cuts all of my visualization research pertains to methodology, and in particular, qualitative evaluation methods. So what I was especially interested in at the outset of my PhD, and continue to be now, is how we evaluate visualization out in the wild, studying people using visualization techniques and tools in non-laboratory, real-world contexts. So as a result, most of my work pertains to and includes qualitative evaluation. It's very central in a lot of my work. So two of my dissertation projects, including the energy management design study that you'll hear about, involved formative or pre-design evaluation. And the focus of these evaluations is on understanding why and how current workflows or processes are performed so as to inform future visualization design. So this includes examining what are the current domain conventions that are happening, what are the problems and constraints and workarounds that people are doing to get their jobs done when the tools fail. And often this involves interviews, analyzing the artifacts that people are using, and task analysis. So along with Sheila Carpendale and Melanie Torrey, Bongshan and I actually wrote a paper about these methods at Believe a couple of years ago. So I'm also very much interested in studying the adoption of visualization techniques and tools. So once something is deployed or disseminated, I want to know who the early adopters are and whether they're using the tool or technique for the same reason that was envisioned by its designers, or whether it was appropriated for some other purpose. So evaluating visualization adoption and appropriation, it's exceedingly rare in the visualization research literature. There was a 2012 survey by Heidi Lam and colleagues about visualization evaluation. They surveyed something like over 800 papers, and only 5 of those that they found had commented at all on whether the tool or technique was adopted by its intended user base. So with respect to my own research, we have a paper from 2014 that documents the adoption of a deployed document visualization collection tool. And this was done by 5 self-initiated investigative journalists. We didn't ask them to adopt the tool. They took it up out of their own volition just about hearing about it. And none of them had contributed to the preceding phases of design. And to understand these cases of adoption, I relied upon interviews that involved both retrospective recall of their analysis process and reenactment of their investigative process, asking them to walk me through their process. I would take screen capture recordings, analyze their interaction logs from their use of the system, perform a task analysis to compare these case studies against each other, but also to our preconceived notions of what the task we thought the tool would support. In this case, we ultimately found that some of the journalists were using the tool for a task that we did not initially foresee. And subsequent deployments of this tool included some explicit support for this initially unforeseen task. So altogether here, the challenges of evaluating visualization techniques and the tools, it provided me with an opportunity to develop my qualitative research skills. Prior to this, I'd been doing mostly quantitative work in my master's and my undergrad research. So this involved taking research methods courses and learning about different theoretical perspectives and methodologies from the sociology, anthropology, and educational psychology traditions. So now while I've told you about how my work cross-cuts different types of papers in the Viz community, as well as how evaluation plays a large role in my work, this diagram presents another perspective. It's how I illustrate my expertise, which pertains to task analysis for visualization. And I've applied my approach to task analysis in both visualization design and evaluation-focused projects, spanning different data types, as well as projects spanning different discovery and presentation-like tasks. You'll hear about some of these today. So I don't have time to speak about all these projects in detail, but of course, if you want to speak one-on-one with me afterward, I can go into all these projects in much more detail. But I'll speak about these first 3 on the list. Yeah, I'll go into detail about our task typology first, then follow with our energy management design study work. And then finally, I'll finish off with a timeline project that I was working on here last summer and continue to be now. Okay. So our 2013 InfoVis paper, it's called A Multi-Level Typology of Abstract Visualization Tasks. So this is a framework paper that proposes a way to classify visualization tasks in a data type or domain agnostic or abstract way. This is the first paper published out of my PhD work, and it served as a framework for guiding my other projects, the design and evaluation components. And if some of the material that I'll present in the next few slides seems a little bit familiar, it's because this task typology was also later used in my advisor Tamar Munzner's 2014 book, Visualization Analysis and Design, which he spoke about here, I believe, around the same time last year. Anyway, so why do we need a typology of abstract visualization tasks? Why do we need to classify abstract visualization tasks? So my answer is that the space of possible visualization design choices, it's very, very large. And while some visualization design choices may be straightforward for instances where we have simple data or simple, straightforward tasks, it's often the case that we are dealing with complex tasks, complex sequences of tasks, and complex data. So imagine that every one of these points in this diagram, it represents a design choice. That might be a particular visual encoding technique. It might be an interaction technique. It might be some combination of visual encodings or interactions. So an abstract understanding of tasks allows us to operationalize this visualization design process and navigate this design space more effectively. So for any combination of data and tasks, there may be a few good design choices. There may be some suboptimal alternatives that might work in some circumstances, but not others. And there's certainly many poor choices that are incompatible with either the data or the task or both. So if I can only speak about tasks in the context of a single domain, so say, for instance, in energy management, I'm speaking about energy consumption data, I might be missing out on viable design choices initially intended to address similar tasks or data types from another domain. Say, for instance, financial portfolios, for instance. So both of these domains likely involve the abstract task of identifying extreme values or outliers in quantitative time series data. So I should be considering techniques to address this task irrespective of what domain they were initially proposed in. So what we set out to do in this project was to introduce a vocabulary for describing tasks abstractly, to promote this cross-pollination of visualization design choices across these domains, and to enable communication between visualization practitioners, designers, and people in these domains. My personal motivation for doing this project was that I was just in need of an analysis framework to make sense of the data that I'd been collecting in these very specific domains, relating to why and how people were using visualization tools or techniques. And I wanted to communicate these findings back to the visualization research community in such a way that they would generalize to other application domains, other than the ones that I happen to be studying. So another motivation for this work is that there was a need for consensus. There's an abundance of related work in this area, just characterizing tasks, goals, processes, activities, interactions. And these are in the visualization literature, the HCI literature, visual analytics, cartography. But they tend to vary in a number of ways. So the first is that these prior classifications of tasks and all these things, they vary in terms of the level of abstraction. So some of these are very specific at low-level interface events like clicking, pointing, dragging, while others are quite high-level, sense-making, information foraging, integration of insights. And meanwhile, there's another way to look at this space, is that some of these prior classifications of tasks, they're very domain-specific, or they're specific to certain data types, like task taxonomies pertaining to graph visualization or tree visualization. And many of these prior classifications are atemporal. They're just a list of tasks. Some of them impose a hierarchical task decomposition, while others are more of a sequential form of thinking. So in this project, what we tried to do is we attempted to unify dozens of prior classification frameworks and their theoretical foundations to connect the low level with the high level, to develop this common lexicon or vocabulary for describing visualization tasks and task sequences so that researchers and practitioners could use that to communicate. So our typology of visualization tasks, it's organized around 3 questions. And the first of these questions is, well, why do people visualize data? So ultimately, people visualize data in order to consume or produce information related to a domain-specific goal or interest. With regards to consuming information, a person may have the goal of discovering phenomena within their data. She may be part of an audience to which some phenomena is being presented to. Or she may be indulging a casual interest in data with no other preconceived objective aside from enjoyment. With regards to producing information, so I want to emphasize that visualizing data, it's an interpretive act. Many visualization tools and techniques can and should provide the means to produce these interpretations of the data, maybe in the form of annotations on the visualization, visual encoding, or recorded stories or workflows. In other cases, the goal might be to explicitly derive new data or based on these interpretations. like deriving ordinal ranks from quantitative values, or deriving a set of synthetic dimensions from the use of dimensionality reduction techniques. So in addition to this distinction between consume and produce, we distinguish the ways between how people search for visualized elements, as well as how people query the data in a visualization artifact. And this allows us to specify why people visualize data at multiple levels. A person may locate and identify a visualized element as part of a discovery task, or a presenter may ask their audience to compare multiple items. So our approach also involves characterizing how a task is supported by a visual encoding, an interaction, or a view coordination technique. These may be specific techniques, or we can use abstract terms here as well to describe things like filtering, navigating, selecting, or arranging items. And finally, our approach involves describing the input and output of a task. And altogether, this why, what, how structure, it allows us to chain these task descriptions together into sequences of interdependent tasks, where the output of one task serves as the input to a subsequent task. So this all seems very abstract. I'm going to give an example now from one of our other papers. Here, I'm going to present an example of a task sequence from our typology, but it's based on a task sequence that we presented in our 2014 Belief paper, where we interviewed people who visualized dimensionally reduced data. So in this one case, a person who had high-dimensional data used a dimensionality reduction technique to derive a two-dimensional projection of their data. And this served as the input to a subsequent discovery task in which the person explored and identified clusters in his data. And he visually encoded this as an interactive scatter plot that he could navigate and select data points. And finally, he recorded his interpretation of these clusters and categories in his data by annotating selected sets of data points with categorical labels, which were then encoded as color on the points. So I've used this task typology throughout the other projects in my dissertation. And I've used it to describe the use of existing visualization techniques and tools out in the wild, to evaluate a novel visualization tool, and to inform some visualization design choices. And I'm going to speak about that in the next project, the next section of my talk. So our typology has also been very well received and adopted by the visualization research community. So at last check, it's been cited over 65 times, according to Google Scholar, making it one of the most cited papers from InfoVis 2013 onwards. And I took a look at all the papers that cite it and what people are doing with it, which is pretty interesting. This typology has informed the novel data type task taxonomies that people have used this vocabulary to describe what people do with node-link graphs or cartograms, as well as domain-specific task taxonomies, using this vocabulary now to describe things that are happening in bioinformatics or malware analysis. But now we have a common vocabulary to which to use that. So people have also used it to communicate the procedures of experimental studies. And finally, it's been used to contextualize the capabilities of some novel visualization tools and techniques. Just what are these tools for and how they might generalize across different domains. So after developing this task typology in 2013, my next goal was to apply it in a design project, where I would choose the visual encoding, interaction, and view coordination techniques to address tasks related to a concrete domain problem. And this is what I worked on for the better part of the next year or so in the domain of energy management. So the first step in this project was for me to understand the problems that people were facing in this domain. With the following. Given a portfolio of buildings, for example, you have a university campus, you have a hotel or a restaurant chain, or a city's municipal buildings. The energy manager or analyst person, they have to do several things. They have to determine which buildings in their portfolio require energy conservation measures, like installing new windows or lighting or insulation in these buildings. And then they have to assess the performance of these buildings in a portfolio following the implementation of an energy conservation measure. And then they have to find and diagnose anomalous things that are happening in their data, like spikes or other forms of erratic or inconsistent behavior in these energy portfolios. So these very concrete domain goals, they were identified as part of this work domain analysis that I had done, where I learned the vocabulary of this domain. I interviewed the stakeholders involved, which included not only our collaborators at this software company, but also their clients who are located at organizations across North America, including a few large universities. And our collaborators had an existing energy management software tool that they had already deployed and that some of these clients were already using. So I was trying to understand why, how, and when this tool was being used and what its shortcomings were when it broke down and when people would do their own ad hoc analysis. So our collaborator's existing tool, it was fairly limited. It relied upon grouped bar charts and superimposed line charts like these here for understanding and comparing patterns in energy consumption and demand amongst an organization's many buildings. So as you see in this simple diagram, these choices were okay, but they didn't scale very well if you wanted to compare more than a handful of buildings, these group bar charts and line charts. Maybe a small handful, but certainly less than 10 before it gets difficult to tell one from another. And our collaborators wanted to address cases where you had dozens or hundreds of buildings. In other words, these choices, they were okay for some selective sets of drilling down into a small subset of buildings in the portfolio, but certainly not for large overview cases. And it was also very difficult to navigate between visualizations in this tool, which is a problem. So based on the domain problems that we identified and in further consultation with our collaborators and their clients, and by looking at their existing tool, I then applied this task typology of ours to identify what abstractly these tasks were and in what sequences might they occur. So first I realized that the energy analysts need to discover some coarse phenomena in their time series data, which an analyst has to be able to look up a portfolio or a group of buildings and summarize aggregate energy performance over a long period of time. So next, the analyst should be able to drill down to discover some fine-grained phenomena, typically in a smaller subset of buildings and over a shorter span of time. Be able to locate and compare phenomena between buildings, as well as within buildings, comparing one building 1 year to the same building the same next year or the next week to see what had changed. And finally, the analyst should be able to identify the contribution of energy consumption of one item relative to its parent, such as from a single building to its group, or from a group to the entire portfolio. And as you note, typically these are done in some sequence or another. Sometimes starts with drill down, sometimes it starts with the overview. And we notice that some people need to be flexible to move between these tasks. So given the type of data that our collaborators had, along with the set of tasks that they wanted to perform, so I then was able to expand this design space by considering possible visual encoding, interaction, and view coordination design choices that were appropriate for summarizing, comparing, and identifying phenomena in multiple concurrent time series data, irrespective of what domains these tools and techniques were originally applied in. So some of these choices, they were discarded as they didn't scale to the portfolio sizes that we were considering, or they violated some convention in the energy domain, which is another interesting topic that I'll return to at the end of this talk with some ideas for future work. Or they were a mismatch for the tasks that we were trying to address. So to test out these alternative design choices, my design space exploration involved the development of what I call data sketches, or minimally viable yet functional interactive prototypes containing real and representative data. In this case, taking real data from client building portfolios and working with it. So I developed this Sandbox environment for rapidly testing out visual encoding design choices and view coordination design choices. So at first glance, it might seem that what you're seeing here, this is the Sandbox environment that I built. It might seem like it's a high-fidelity prototype of a tool that the energy managers will eventually use. This is not the case. This is an interactive environment for me to use as a designer to test out different ideas. This data sketch and Sandbox prototyping approach, it involves foregoing some traditional HCI prototyping approaches like paper prototyping. Discourages the use of things like toy data or template data. The goal of this approach is about encoding and interacting with real and representative data as soon as possible in the design process. So this is one of the first things that you do in this project. So I use this Sandbox environment to conduct chauffeured demos with collaborators and stakeholders to better understand task sequences. And by a chauffeured demo, I mean piloting my Sandbox environment in response to during interviews with these people, asking them what do they want to see and where do they want to go next from this view of their data. And this was as a means to gather feedback on these different visual encoding, interaction, and view coordination design choices. And what I would do, I would record these chauffeured demos with screen capture, and I would transcribe what they would say. And this would help me not only to identify what visual encodings and interactions were appropriate, but also how to coordinate these multiple visual encodings or interactions within an interface, such as how you would juxtapose multiple visual encodings in a single display, or you would sequence them in a series of displays for drill down cases. And this is just reflected in this one flowchart example with some commentary that I've sanitized here from our collaborators. So ultimately, through this process of iterating on visualization sandbox, visual encoding design, and chauffeur demos with a series of our collaborators and their clients, some of them who weren't participating in preceding phases of design, they joined later to get new perspectives. I ultimately identified a small set of matches between visual encoding, interaction, and view coordination design choices, and the tasks that we were addressing. So the value of our research was in documenting these trade-offs between about a dozen different alternative design choices and why our final solution was effective. So here's a series of screenshots from our collaborators then adopted a number of our visualization design choices and implemented them into the production version of their tool. Starting with the left, we have a series of coordinated summary box plots and a matrix-based encoding for multiple buildings that you can scroll and see high-level trends over course periods of time. And I'll speak about this design later in the talk as well, about some ideas for future work here. And then being able to drill down to then look at small multiple or faceted bar and line charts for this drill down task, looking at a smaller subset of buildings in the portfolio over shorter periods of time. And finally, on the right, we have stacked bar and area charts for this roll-up task, which allows the person to identify contributions from one building to its parent group, or from a group to the entire portfolio of energy consumption over time. And as well, the ability to directly transition from one task to another quickly, because the preceding tool that our collaborators had, it was very difficult to navigate between one visual encoding to another. So our paper about this it's beneficial to the visualization community, not only because it presents evidence for why these design choices work for these tasks, but because we describe the data and tasks abstractly, these design choices may very well generalize to other domains involving the comparison of multiple time series data. Rob?
Can I just get a sense of what the really high-level task for these folks are? Would it be something like troubleshooting? Would it be something like long-term planning?
It can be both. So sometimes they're trying to figure out, was there an anomaly in a building? So was there a spike? Was there an outage? And what caused it? That might be one case. And that's when you would look at this drill down case to go into a shorter period of time and maybe a smaller set of buildings to look at these anomalies. Mm-hmm. But at the higher level, it could be about planning. So it could be about, I just implemented an energy conservation measure. I just installed new windows in this building. I want to see over a long period of time, did this have any effect? Did my energy consumption go down? Yeah. So our paper actually goes into a lot more detail about our methodology, the impact of domain convention, and the topic of familiarity with or literacy with different visual encodings. So some of these, especially the one on the left here, which I'll return to a bit later, they've never seen this visual encoding before. And it's a topic that I'm very much interested in, and I'll continue this discussion later. So the last project that I want to speak about in detail today, it's not one that appears in my dissertation, but it's one that was largely done here at MSR as an internship project last year, and it's continuing now. So my motivation for doing this project was that in my preceding projects, including the energy management design study, they were all about discovery tasks, analysis tasks. This one was an opportunity to turn my attention to another kind of task. This was about presentation and storytelling. And while both the energy management design study and this project involves time-oriented data, the former involved quantitative time series data, very large quantitative time series data, while this project involved smaller, curated data sets of interval event timeline data that you might associate with biographies or historical summaries. And in addition, I was excited by the prospect here that techniques that I could develop in this space might be of interest and could be adopted eventually by journalists, especially because we see a lot of timeline stories appearing in news media, especially when bringing someone up to speed on a current event. So I'd like to motivate this project just by showing this classic 1765 information graphic drawn by Joseph Priestley. And what he's done here, he's visually encoded the lifespans of several dozen notable statesmen and men of learning. And he's done this along the x-axis, just indicating when they lived. And he's offset them in the y direction just to avoid occlusion so that he can write their labels and you can see when people lived and when people were alive at the same time. So this form of visual encoding for timelines, it's become the dominant way that people present timeline data for the past 2.5 centuries. But it's certainly not the only way to show this form of data. So in this project, we surveyed about over 250 instances of tools, techniques, or artifacts that visually encode timeline data. So beginning with this leftmost column, some of these were handcrafted information graphics that appeared centuries ago. And others, more recent information graphics that you find online or on news sites. And these tend to be done using illustration software as opposed to being hand-drawn. Although there's some interactive examples of timeline infographics that you see online. We also looked at interactive timeline visualization tools intended for discovery tasks. There's quite a few of these, including some work done here, the third one, that a lot of this work has been done in the domain of electronic health records. And they're typically with larger data sets you're trying to find patterns in. So not for presentation tasks so much, but more for discovery and analysis. And finally, the last couple columns there, we encountered a set of interactive timeline visualization authoring tools. This is, again, for presentation. We found about a dozen of these, and some of them are quite popular. There's one called Timeline.js, which is one of the top, actually the one on the bottom here. And these are tools that are especially popular amongst journalists. They just allow a person to upload a spreadsheet of dates and descriptions for these events, and the tool will output a basic interactive timeline that the viewer can page through or select an event. But they all kind of look the same. And when we considered this corpus of timelines as a whole, we actually found that there's quite a bit of variety, a very rich variety of highly expressive and aesthetically pleasing design choices amongst the historical timeline information graphics as well as the modern information graphics. But none of these encodings, including circular, spiral, or even arbitrary shaped timelines, this is by Mark Twain, actually. These representations of time, none of them had made their way into modern interactive visualization storytelling tools. And we were wondering, why do they all assume this chronological form of Priestley's timeline? They all look like this. So we wondered, why is this? When is a linear chronological visual encoding appropriate? And when are other timeline encodings the right choice? And what if you have a story that isn't well suited by one particular type of visual encoding for timelines? What if you have more points to make that don't suit that mold? So based on this extensive survey that we did, we developed and proposed this design space for timelines. And then there's 3 dimensions of this design space. The first of which, along the top, is the representation or the shape of the timeline, from linear, grid, arbitrary, spiral. Grids might be a calendar timeline. The second dimension, scale. It corresponds to how events are mapped to positions along the timeline. And finally, its layout. Whether the timeline is just a single timeline, whether there are multiple timelines side by side that you're meant to compare between, or whether a timeline is segmented at meaningful boundaries like days or years. Sometimes you might want to separate one timeline for 1 year and look at the timeline for the next year, with segments shown separately. But if you do the math here, there's 100 possible combinations of representation, scale, and layout. This doesn't mean that there are 100 viable timeline designs. When we looked at our survey data, we only had existence proofs for a subset of these combinations, somewhere between 20 and 30 combinations here. And even among this subset, there were designs that asked the viewer to make some very difficult perceptual judgments that we deemed to be pretty ineffective for making good judgments. So the way to constrain this large design space was actually to enumerate the tasks that mapped these combinations of representation, scale, and layout. So we ultimately were able to identify 20 viable combinations of representation, scale, and layout that map to meaningful tasks that the viewer is supposed to perform, or possible story points that map to those tasks. So these are just 3 examples. There's 17 more that we describe in our paper of examples of story points that vary either in terms of representation, scale, or layout. So for instance, on the left, we have a single linear chronological timeline. This might be effective if the task of the audience is to identify the chronology or duration of events. In the middle, a radial chronological timeline that's segmented at meaningful temporal cyclical boundaries, like days or years, cycles. This might be effective if your audience is intended to compare the periodicity of events across these segments. So naturally occurring weather events is one example here, like comparing the periodicity of tornadoes or hurricanes over multiple years or days. And then on the left, we have an example of multiple linear timelines with a sequential scale. In the sequential scale, we remove all the chronology or duration of it. We just keep the sequence of events in their order. This might be effective for comparing the number of events that appear in these timelines. So to then verify that these 20 meaningful combinations of representation, scale, and layout actually work, I built an environment that allowed me to test all of them. I built this interactive sandbox environment that allowed me to test these combinations, and I loaded it with 28 representative timeline datasets. And many of these datasets were actually based on or inspired by existing timeline infographics that we'd found in our survey. So here's a gallery of timelines that we generated with this sandbox environment, with one timeline presented as an example for each of our recommended or meaningful combinations of representation, scale, or layout. There's 20 of them. It actually continues down. And we also present here, you'll see some commentary about what the narrative point or what the task that the audience, the viewer, is expected to perform with these examples, these timelines. But the next question here is, well, what if you have to tell a story that asks the viewer to perform more than one type of one of these tasks? Or if you want to exclude parts of your timeline to focus on a specific interval in your data, a subset of the events, if you wanted to highlight things. So one option would be to present a static, a slideshow of static timeline images, but that has the limitation that your context isn't maintained from one story point to the next. You can't allow the viewer to interact with your timeline data and explore some of the events. So for this reason, we explore the possibilities for animated transitions between points in this design space for changes of representation, scale, and layout. So here's an example of a representation transition from linear to radial. So representation transitions, representation of radial timelines here. They have the aesthetic advantage of a square aspect ratio. But their drawback is that you're making arc length comparisons as opposed to comparisons of length along a rectilinear axis. So there's strengths and drawbacks to all of these combinations. If you're curious about the timeline data being shown here, it's actually just my biographical data colored according to categories like academic, professional, and athletic achievements. And some of it you already saw. So here's an example of a scale transition. So this is another type of transition that just changes, in this case, from a chronological scale to a log time scale. The data shown here is the lifespans of notable philosophers spanning thousands of years. And they're colored by world region. So we have all the Greeks over here and all the Germans in purple at the end. And when you shift to a log scale, you're going to be emphasizing more of the recent people on this timeline data set. Finally, this is an example of a layout transition from a single timeline to multiple timelines, in which we have events from each category of events, and these correspond to the colors here, that they're moved to their own dedicated timeline. The data shown here is the set of, yeah, Mary?
Did you pick these because they're somehow more representative of the kinds of timelines that actually exist out there?
Yes.
Why did you pick these?
So this data set was in a timeline infographic that I saw recently. And similarly, the philosopher data set was, I'd encountered one in my survey, and also it was similar enough to the Joseph Priestley example enough before of biographical timelines of who lived when. They're fairly common, those type of biographical who lived when type of timelines. This is the set of armed conflicts that America has engaged in since independence, colored by world region. And the data gets split into multiple timelines where each world region gets its own little timeline. So the culmination of this work, yeah?
So why are the animations helpful?
For tracking, maintaining context from one state to the next. So you can see when some event moved to another form, a representation, or scale of timeline.
Do you think that works? Is it true?
We haven't tested it yet, but we'd like to. That's the next step of this, is talking to users. And I'll speak about where I want to take this work next, and that includes actually showing these to people and getting feedback on them.
I mean, how do you relate that to the work that like Jeffrey Hare and George did on?
Yeah.
Well, even polyarchies started doing some of this stuff way back.
Yeah, and we actually refer to this work for constraining the space of animated transitions, because we don't want to do any transition from one state to another. We actually constrain it to just these types, only altering one dimension at a time, so that they're less jarring. So it's just changing representation or just changing scale. And if you combine that with selective highlighting, when you can dim out some of the events in your timeline, you can actually follow just a small set of these events if you have emphasized them. So that's one additional storytelling thing that you need, another ingredient that you need to add to this to make it work. And that's what we did here, and that's what you're seeing in this little timeline story. It was the culmination of all of this, putting the dimensions of our design space together, the 20 recommended meaningful designs, and over these 24 real data sets. Here's an example of selective highlighting. So if you're just going to selectively highlight a few of them, they're easier to track, because we can't really track that many objects when they're in transition. So in order to actually tell a story, we added some, you see some captions along the top. We have selective highlighting and filtering. Categorical legends, of course, are helpful for determining which is which. By the way, the data of this data set is the daily creative routines of highly creative people. People like, we have Dickens and Darwin. This, again, is based on an existing timeline infographic. I've seen several of these that have had presented this in static form, but in one of them I encountered was in these radial chronological diagrams. Another one was in a linear format as well. And they have their own advantages. They afford different tasks. We actually presented we produced, using this environment, 7 stories like this. We recorded little data videos with timeline data sets like this. Here's an example of a transition from chronological to sequential. So before, you were able to see on a 24-hour clock what people were doing at any time of the day. Now, this is about counting the variety of events in their day, how people changed in this case, what they were working on or what they were doing during the day, either a creative task or sleeping or eating.
What does the axis mean?
Just the number of events. It's the number of unique events. This is a sequential scale. It just keeps the sequence, but not the chronology anymore. Of course, it's not as ideal as looking at it like this. This linear representation, it affords the comparison of how many unique events to a greater extent. And here's an example of selective highlighting where you can compare. In this case, it was Darwin and I think Haruki Murakami. And I think there's actually one final transition in this video where I transition back to a chronological scale. And using this representation, now you can look at synchronicities. So what people were doing at the same time in a day. And actually, one of the timeline infographics that this is based on assumes this form, whereas another timeline infographic has the radial representation with little images of the people inside. So what I'd like to spend just the rest of this my time here talking today, just about what my vision for the future of my visualization research, and I'll be speaking about some of my short-term and longer-term research interests and goals. So starting with this project, and this addresses Danielle's comment, the next step for this project is to get feedback from people on this design space and on our Sandbox environment, ideally by speaking to people who do storytelling, people who work in journalism, work in digital humanities, law, other domains that have timeline-like data. Ideally by populating data, populating the Sandbox with data that's personally relevant to them, asking them to provide their own data, because that's what I have done in previous projects, and I want to do that here. And working with them to produce stories that are relevant to them. And this process will then inform the design and development of some more of a web-based storytelling authoring tool rather than the Sandbox environment that I've already built. So I believe that it's feasible to collect this feedback and develop this authoring environment and deploy it ideally within the time frame of a postdoc here. Now, one of the important research questions in this future work pertains to how we should evaluate visualization authoring tools like this. What are the right metrics to use, and what are the methods that we should do to evaluate authoring environments for storytelling? What are the goals of them? And as part of this evaluation, ideally, we would hope to analyze some cases down the road of whether this tool is ultimately adopted and who adopts it and what are they using it for. Now, another short-term research goal, and this goes back to the energy management design study for a moment. It's to better understand the interaction between a person's familiarity with a visual encoding and some patterns of view coordination or coordination between multiple visual encodings in a single display. And this would be experimental work motivated from, as I said, the findings from that energy management design study. So one of our designs, I showed a few slides ago, and now I reproduce a version of it here, similar to this, that our collaborators ultimately adopted into their tool, was this juxtaposition and interactive coordination between a tabular encoding of aggregate time series values and summary box plots for the same time series period. So this design was actually very well received by our collaborators, and they put a version of this into their tool, despite the fact that neither of these visual encodings had ever been used before in that domain. And when they were shown in isolation, they weren't particularly well received. Something about putting them together and interactively coordinating them made it work and made it appropriate for their task. So I want to study this phenomenon in greater detail, in a more of a controlled laboratory setting, to find out when we have pairings of visual encodings, or one is more familiar than another to the person, or when both are totally unfamiliar, and seeing where these pairings make sense and when do they work and when do they fall short. Another factor to consider within this experiment would be the degree of interactive coordination between these pairings. Is it enough just to show two static encodings next to each other? Or is there some unidirectional coordination between the two, like here, where I'm brushing over one encoding and it's affecting the other? Or is bidirectional encoding important? And we want to test this with different pairings of visual encodings. So another long-term research goal, one which I'm already committed to in the design of timeline-based stories, is just how to understand and how to create and evaluate visual stories. Whether this be like a data video format like I showed a few moments ago, or some semi-interactive story, something that's triggered by steppers or scrolling, but something that allows the viewer to stop and pause and explore a little bit locally in the story before progressing with the narrative. And related to this goal is, well, how do we define and measure if the story is engaging or not? What is engagement when it comes to visual storytelling? And as I mentioned with the timeline storytelling project, how to evaluate storytelling authoring environments, it's another thread in this space that won't stop with just the timeline authoring tool. And along with Bongshin, Natalie, and Stephen, I'll actually be attending the Dogstool seminar on data-driven storytelling next week, where I hope to discuss these questions in more detail, hopefully initiate some new collaborations in this space and see where it goes. So in the long term, I'd also like to continue to conduct visualization research motivated by problems and use cases in data journalism and the digital humanities. So education, history, law, policy analysis. So these are domains where there's been a notable increase over the past decade in the adoption of visualization techniques, particularly for visual storytelling. So over the past year, I've become involved with the Hacks Hackers data journalism community in Vancouver, and I hope to participate in this and similar other computer-assisted reporting communities in the future, wherever I am. So I also what happens behind the scenes in these domains. Before the story is told, how are people in journalism or other digital humanities domains doing their analysis using visualization techniques or tools to perform these investigations or wrangle their data? And motivated by this, I'm particularly interested in visualizing document or text-based data. And this is inspired by this document visualization tool overview that I studied in a field study several years ago. Now, a unique challenge for data analysis in many of these domains is that the goal is seldom to discover an objective truth in the data, but it's really just about promoting and recording multiple interpretations of possible phenomena. And the tools and techniques that we build have to reflect this more interpretive approach to analysis rather than sort of a sense-making or discovery-based approach where there is a ground truth, something that's motivated by more like intelligence or law enforcement. Okay, so to conclude, I just want to indicate why I think MSR is the best place to conduct this visualization research, and in particular the visualization research that I want to work on in the near term. So first, I'm keen to continue this ongoing positive working relationship, working with some leading people in the areas of visual storytelling. So in addition to Bongshin and Natalie, there's Stephen's work on presenting and animating data with Sandbox, which I saw him demo here last summer. And there's, of course, Curtis's history of developing rich, interactive, story-based media. In short, there's just a wealth of experience here in this space that I love to learn from. Another attractive aspect of MSR is that its aims are not domain-specific. Microsoft products are not exclusive to work settings or single domains like business intelligence. And I feel like Microsoft and MSR by extension. It has the ability to affect the future of not only how people work, but how people conduct research, how they create, how they play, all the ways that people consume or produce information. And I feel that visualization research spanning many different application domains, data types, and tasks is just a surefire way to continue this cross-pollination of visualization research design and design choices across these domains. And finally, I'm drawn to the potential for multidisciplinary collaborations. So this could mean some more problem-driven visualization design study type work motivated by application domain problems, like visual analytics collaborations with statisticians, machine learning researchers here. I believe that there's great opportunity for visualization to help people learn how these machine learning and statistical methods work. I know that there's some work like Model Tracker here that are in this space. Another possible collaborations could include work on document-to-text visualization with natural language processing and computational linguistics researchers. And finally, I'm interested in assessing and promoting individual health and well-being. This started with, as you remember from the beginning of this talk, my master's research motivated by the development of a self-administered cognitive health assessment test. My undergrad research is all about using technology to promote and enable physical activity. Though I didn't speak about it, I want to actually return to it in the space of visualization. And considering the recent popularity of self-tracking or the quantified self movement or innovations in wearable technology, I believe that there's great opportunities now to promote both cognitive and physical health. I think it would be great to explore the ways in which I could collaborate with groups here in this area and other areas related to personal data visualization. And I feel like MSR was designed around fostering these multidisciplinary collaborations, and I look forward to hearing your ideas about projects that we could work on together. So with that, thank you very much for your attention, and thanks for these people for giving feedback on the slides. Look forward to hearing from you and meeting with you in person. Thanks.
One quick question.
Yeah.
A theme in a couple of your research projects has been sort of developing a sandbox where you have lots of different varieties, experimental tools. Now, the difference between sort of paper prototyping is that that's a lot more work. Paper prototyping, you just do this. The difference between this and high fidelity is this is meant primarily as a chauffeured tour, as you said, or is it? It's more a tool for you to visualize it as opposed to someone else using it.
It's the divergent stage of design rather than the convergent phase. So it's about developing just this way to quickly try out different designs really early on in the design, but making sure you have real data in there.
I think that's visualization, at least, that's one of the things we see a lot.
That's like the limitation of, I still do a little bit of sketching in the beginning, but often it's just like napkin sketching, and before you actually get into needing to really put the real data into it and see if it works.
So are there existing Sandbox tools out there, or do you kind of have to build your own each time?
In these two projects, I've built my own in both these projects. In the first project, energy management, there was some data wrangling packages that my collaborators had already built that helped get the data into it, which was nice. And they had done all this work in R. But then I had to build this sandbox environment over top of it, and I was using a tool called Shiny, made by RStudio, which I found very helpful for quickly getting an interface together and trying out different visual encoding options. And once you're in the R ecosystem, there's so many R packages for visual encoding and data that you can just hook up into this Shiny web-based interface. Yeah. The other one was in D3.
I was going to ask further on that. Where does it's a blank HTML page today, and it's a sandbox begin? Besides, you've got an SVG tag and you've written a little data.import foo.csv. What makes it a sandbox?
I think having the interaction, being able to choose between different visual encodings within the interface, having those interactive controls there for not only changing the visual encoding, but also changing the subset of the data, being able to filter is very helpful. Have that within the interface without having to go back into the source code. Especially during a live chauffeur demo, I want to be able to quickly change which data is being shown, highlight parts of the data, aggregate. Having that done interactively is very helpful.
I hear that. I'm trying to figure out which part is sandbox infrastructure and which part is you build five visualizations in advance. didn't bother making the interfaces easy to use because you knew that you'd be the only person, and then, you know, clicked through the 5. Which is cool. I mean, I'm fully in favor of that. I'm just trying to figure out I'm trying to formalize in my mind what Sandbox is, whether there's a stage in my design process where I should be incorporating the Sandbox notion.
I think it's probably after that phase where you developed a few standalone interactive prototypes. But particularly in my case, where I want to understand what the task sequence is and understand how we can quickly go between them, I find that it's important to be able to do that interactively. Because then some of the design choices that are in the Sandbox do end up continuing and being adopted by our collaborators. So it's helpful to have that already envisioned. And especially with the second project, the timeline project, there is that first phase where you just develop a bunch of standalone ideas. But having the ability to filter and aggregate and highlight is very important.
It maintains state between the different views so that you can select over here, then flip visualization.
What would this filtered data set look like in this representation? Okay, now let's switch for that.
Got it. So the Sandbox is a data management system and a state management system, plus the ability to jump between viz,
context
but maintain that. Okay.
Yeah, Cora?
So the early work on the task topology, as you mentioned, it's influenced a lot of different areas of InfoViz. And part of that was the goal to try to bring this unification.
Yes.
Were there people that have adopted it that surprised you or that sort of weren't expected?
Yeah.
And tell me about.
I could tell you about the weirdest example. A master's thesis at, I think it was the university in Germany, on human-plant interaction. So it was a MFA thesis about when do you design and grow plants in a particular fashion in response to data. Very weird, very confusing, but he used the vocabulary of our typology to describe when a certain design would be useful for a particular goal, to translate some findings in the plants and how they were grown. That was the weirdest one. But people have been using it in a lot of things that we did expect, which was nice. So in a design study, in a particular domain, it might not be very useful to just talk about those very specific domain tasks, but now those findings can be communicated using this vocabulary. And we've seen a few instances of that, at least one in bioinformatics, and a few different domains. I mentioned malware analysis was another domain that people have used our vocabulary for. So most of the time, it's been these cases where we did expect how it would be used. What I have liked is that people have been still continuing to taxonomize tasks in very specific data types or domains, but they're now using our vocabulary to allows this translation to happen a little bit more easily now.
And it's still, I mean, the paper's not that old, but how, within the InfoViz community, your main community, how well adopted do you think it has been even in sort of the last year and you foresee it going forward? Is it still, well, yes, a few people are using it, or are you seeing sort of growing adoption?
Yeah, at the InfoViz conference this past year, I saw quite a few people citing it and actually building off of it, or saying, this is our new tool, and according to the task typology of Bremer and Munzner, this is now the tasks that our tool supports, and we use this vocabulary. And some people are actually adopting some of our little diagrams that we have too, just mimicking the visual style of it too, which is really amusing. Yeah, Salima?
So just to follow up to Corey's question, have you found that it's broken down in any way based on people using it, or you had to iterate on it and change things as a result of people trying to use?
Yeah, we have done a little bit of iteration on it in our belief paper the next year. We did sort of do a little bit of rearrangement based on what we thought made more sense, especially around these produced tasks. And there's been a few instances where some people have said we couldn't really fit our tasks into this mold. Particularly on the visual analytics side, because there's a whole bunch of other tasks that are involved in that process that may not really fit this visualization-centric task typology. So there was a paper by Michael Settlemeyer and that group out of Vienna on visual parameter space analysis. And they actually admitted in their paper, we tried to fit their tasks to this typology, but things like sensitivity analysis and a couple of their other tasks in this paper, they couldn't really find the right terms to fit it. Which I think is fine. It's probably appropriate in some cases, but not all cases. And especially with these more visualization-centric projects, it may work better than if you're looking at visual analytics or things where visualization is part of, but not the entire picture. Thanks.